Hi, and this is section 8.4, and it's entitled Using Scientific Notation. We are on page, right now, page 512. I'll just put that here. Page 512 of your textbook. I perceive scientific notation is something you have learned to do or learned to use before, but just in case, I'm going to treat you as if you haven't learned it. I don't think this video will need to be very long. So we'll get this going right now. We'll walk through this one more time. If nothing else, if you have learned it before, it'll be a good refresher, okay, of what it is. So first of all, what is scientific notation? Scientific notation is just a shorthand way of writing very long, large, or small numbers. You know, like long, large numbers could be, you know, like if I had 23 quadrillion, which would be 23 with, I'm thinking, right, I think it's 15 zeros after it. Or very small numbers I can write in scientific notation, like if I had .00000000038. That's not very convenient to write. It'd be nice if I had a shorthand way of writing that. So scientific notation is just a shorthand way of writing long, large, or small numbers. So what do you do to write a number in scientific notation? It's an easy three-step process. Let's take this number, millions, billions, trillions, quadrillions, 152 quadrillion. If I want to write this number in scientific notation, which would be a heck of a lot easier than writing this out as a decimal, here's a three-step process. First, you place a decimal to create a number which is at least 1 but less than 10. So, in other words, take a decimal and put it between the 1 and the 5. That will create a number between 1 but less than 10. So that's the first thing. Create a number between 1 and 10. I got 1.52. The next thing I need to do is I automatically write times 10 after that. And now the final thing I need to do is write an exponent for my base 10, and here's how you write the exponent. You have to write a power of 10, which describes how many places you have to move your decimal to get it back where it originally was. So since you put your decimal here, between the 1 and the 5, as you can see, if I start counting, I would have to move my decimal 17 places to get it back where it belonged in the first place. So I'm going to use 17th power. So this number in scientific notation is simply 1.52 times 10 to the 17th power. Obviously, that's a lot easier to write out than this long, drawn-out number, okay, as a decimal. So that's how we can write a number in scientific notation. Let's go through a small number in scientific notation like here. Very tiny number. Not convenient to write. So I'm going to write this number in scientific notation. I follow the same three steps. Step 1, let's create a number that's at least 1 but less than 10. So if I put a decimal between the 3 and 2, I get 3.2. That's definitely between 1 and 10. I automatically put times 10 after that. And now I got to get my exponent. I need to count how many places do I have to move my decimal to get it back where it was in the first place. And when I do that, I notice I have to move my decimal 10 places to the left to get it back where it belongs. Since I'm moving left, I would put a negative 10th power for that. So I have 3.2 times 10 to the negative 10th power. That's the scientific notation for this tiny number. One other thing they'll ask us to do in the homework today, they'll ask us to do two things. They will ask you to write numbers in scientific notation as I've represented here. They might also ask you to do something like this. They might say, write as a decimal. They might ask you to write a number in scientific notation as a decimal. Like if I had 4.28 times 10 to the, let's say, 10th. To write that as a decimal, I write 428, and I have to move this decimal 10 places to the right. So I'm going to go 1, 2. I've already moved it 2. I got to move it 8 more places, which is going to create 8 zeros. 3, 4, 5, 6, 7, 8. This number as a decimal would be right there, which looks like it's millions, billions, 42 2,800,000,000. Okay, that's how I would write a number in scientific notation as a decimal. Or let me give you one more example of that. What if I had 4.28 times 10 to the negative 8th? Well, the negative 8th power would mean take this decimal point, move it 8 places to the left. So I'm going to move it 1 to get it past the 4. I still got to move it 7 more times to the left, so that means I have to create 7 zeros and 4, 2, 8. Okay. Sometimes when you have tiny numbers, it's nice to leave a little space in between every fifth zero to make it easier to count the zeros, which is why I left a little space there. So I have 5 zeros, 6, 7, 4, 2, 8. Okay? So I can write numbers in scientific notation, or I can take a number in scientific notation and write it as a decimal. Let's talk about multiplying numbers in scientific notation. If you look at questions like numbers 39 to 47, this is actually very simple to do. A lot of it comes down to, did you watch the video today? If you did, this would be something I would have you do without a calculator, by the way. All right? Like, take this multiplication, 2.5 times 10 to the 7th, and then I'm multiplying that by 3 times 10 to the 5th. That might look intimidating. It's actually very simple. Just multiply the numbers between 1 and 10 out front. I highlighted that in green. And then multiply the base 10s together, and there's your new number in scientific notation. So 2.5 times 3 is 7.5. 10 to the 7th times 10 to the 5th. Remember, if you're multiplying by base 10, you just add the exponents. You get 10 to the 12th. There's your new number in scientific notation. Very simple to multiply numbers in scientific notation together. On a test or quiz, I'd make it that easy. Okay, I'm not trying to see if you have any mental, hard mental math to do. I just want to know, do you understand the rule of multiplying numbers in scientific notation? Multiply these numbers that are between 1 and 10 out front together, and then multiply the base 10s together, and there you go. You can also divide numbers in scientific notation in the same way. Here would be an example, 8 times 10 to the 12th divided by 2 times 10 to the 12th. Very simple. Just take 8 divided by 2, which is 4. Take 10 to the 12th divided by 10 to the 4th. Remember, when we have the same base and we're dividing, we actually subtract the exponents, which would be 10 to the 8th. You should be getting 4 times 10 to the 8th power. You'll see some questions like that on 39 to 47 to try. Scientific notation to a power, how do I deal with that? How do I deal with 5 times 10 to the 6th, which is scientific notation, squared? Well, just apply. Remember, this is like the power of a product property, which we learned back in section 8.1. You have to square each product. I got to square 5, and I got to square 10 to the 6th. So I'm going to get 25 10 to the 12th. They will ask me to write this in scientific notation. Now, you notice this is not in scientific notation because 25 is not a number between 1 and 10. So I will put my decimal point between the 2 and the 5. Now, think about this for a minute. Right now, the decimal point's here. People always get confused on this every year. The decimal point's here. And right now, with the decimal point here, I got to move my decimal 12 to the right. Well, if I put it here, I just added another place I have to go to the right with. That's now the 13th power. So if I move my decimal from here to here, it took 12 places to move the decimal point from here. If I move it here, I just added one more place. Can you see how I got to move the decimal 13 places to the right. So 25 times 10 to the 12th in scientific notation would be 2.5 times 10 to the 13th. And again, they'll ask you questions like this, and they'll want you to put the final result in scientific notation. Ordering numbers in scientific notation. How do we put these numbers from least to greatest? Got a little error alert. I'm going to have you compare these two numbers. Here's a very, very common mistake that I see every year that people make. I'll ask them to compare these two, tell me which is bigger. And they'll go right here and say this is bigger because 9's bigger than 7. Which doesn't make any sense because you got to look at the base 10. Now think about it. 10 to the 5th is 100,000. This is like having 900 thousandths. 10 to the 10th is 10 billions. This is like having 7 10 billions. The fact that I have a 9 here and a 7 here doesn't make this bigger. This is 900 thousandths, and this is 7 10 billions. Obviously, 10 billions is way bigger. You have to look at the base 10 to determine what is bigger. Okay, so I wanted to make that clear when we order numbers in scientific notation. 10 to the 10th is way bigger than 10 to the 5th, so 7.38 times 10 to the 10th is the way larger number in this case. So when I'm comparing numbers in scientific notation with those in standard notation, how do I tell which is bigger? A couple things you can do. You can either put all three numbers in standard notation, or you could just quickly, and this is what I do, I just put everything in scientific notation real quick. I just rewrote this in scientific notation. That's already in scientific notation, and this one I'll write in scientific notation. And you immediately notice that two of my numbers have an eighth power for base 10. So these two are definitely the bigger numbers. This is definitely the smallest. Now break the tie between which is bigger. Now remember, 10 to the 8th would be 100 millions. 700 millions is definitely more than 100 million. So this number would be the biggest. This would be second biggest. This would be the smallest. And I can order those then. I did it in this case from greatest to least. I did one example problem out of the book. They wanted me to write this number for 42. They asked me to write the number in scientific notation, and actually I should redo the problem. I just put the answer up here, which didn't actually work it out. Might be nice if I work it out. So let's start from scratch here. Let me erase this. If it will erase. Well, if it's not going to erase, I'll just go to a new page. Let's just do 42 from scratch so you can see how I got to there. We had 6 times 10 to the negative third over 8 times 10 to the negative 6. And from earlier in my video you saw when we're dividing scientific notation, we take these two numbers and we divide. 6 divided by 8 is 0.75. So I get a 0.75 times, then I take these two and divide. Now I have two base 10s that I'm dividing. I should subtract the exponents. So in my mind I'm thinking, right now in my mind, what's negative 3 minus negative 6? And I'm coming up with, hey, that's positive 3. That's a positive 3. Okay? So I get 10 to the third. This is not written properly in scientific notation. Now remember, 10 to the third means I should take this decimal and move it 3 that way. This is not in scientific notation because I do not have a number between 1 and 10. So I need to put the decimal here. Do you understand that when I move the decimal from here to here, I just moved it one of those 3 places? I still would have to move it 2 places to the right. So the correct answer for 42 in scientific notation would be 7.5 times 10 to the second. I'm going to stop the video here. Again, I perceive scientific notation as something that you have been taught. I just wanted to make sure in case you have not. So I hope you did indeed watch the entire video. If we have questions, we can talk about those things tomorrow.